Hello, dear student and my dear learner. We had seen about how to draw the resonating structure of a resonance compound, as well as I explained in a last lecture or last video, resonance part 1, about the how to draw the resonance structure. What condition is known as a resonance? Today, among available all the structure, which resonating structure is a more stable? That is our main goal today. So what is the main goal is to find out a stable resonating structure. Before going to that, we see about what is a resonance energy, little bit only in one slide, then we will go to the practical example only. So in resonance energy, there is a graph of a potential energy. If you see here, this is potential energy. Now you must have to remember that potential energy and stability are inversely proportional. So as stability increase, a potential energy decrease. And as potential energy decrease, stability increase. So from this graph we see here, this is one of the structure, total 5 structure we have. So among available all the structure, suppose this is my resonance hybrid. Resonance hybrid means after getting all or drawing all the structure, we are getting one final structure. This is known as a resonance hybrid. After that, this is my resonating structure or canonical structure. This is known as what? Resonating structure or canonical structure. So among this 4 structure, they almost equal, near to same energy. Based on this given data, potential energy and stability are inversely proportional. I can say that this is a highest stable structure. So always resonance hybrid is a highest stable structure. But among available resonating structure, if I want to find out which is a best structure, so from this graph I can say a structure number 2 is a best stable structure because it has a less potential energy among these 4. So among these 4, a less potential energy, so it is a stable structure. According to this relation, I can say. Now what is a resonance energy? I can say this is the resonance energy. So meanwhile, I can say the energy difference between a stable canonical structure, stable canonical structure and resonance hybrid is known as a resonance energy. So 2 minus 1, this is known as a potential, that is known as a resonance energy according to this graph. 2 is what? Stable canonical structure. What is 1? This is resonance hybrid. Dear student, my goal is to find out from the structure a structure number 2, because this is very important for us to find a stable resonating structure. तो यहाँ पे हम दिखेंगे कि हाउ टू फाइंड अ स्ट्रक्चर नंबर 2 और वी कैन से हाईएस्ट स्टेबल कैनोनिकल स्ट्रक्चर और वी कैन से लेस पोटेंशियल एनर्जी कंटेनिंग कैनोनिकल स्ट्रक्चर. Let us go ahead. To find the stability of resonance structure, I have make one picture for you. This picture is always you have to follow, and I make some mnemonic, that is CD on. What is that? CD on. What is C? The first is charge. What is D? Double bond. What is O? Octet. What is N? Negative charge. So now we correlate it. This is charge. This is double bond. This is octet. This is negative charge. And the last, if you are not solved your problem based on CD-on, then there one more is dissimilar charge. I explain you with this example. Normally we have two part. One is charge and uncharged. Always you remember that uncharged is more stable. Uncharged is more stable because increase charge, increase potential energy, so stability decrease. Second, so always where we will find? We find uncharged. Second, increase double bond, then increase stability, because as double bond increase, as increase double bond, the bond formation, a bond formation is exothermic process. Formation is a exothermic process. So I can say as increase double bond, energy will expel out. So energy, potential energy of your system is going to be decreased. So always we find out the double bond. Octet. So specifically period number 2 you have to find. What you have to find here? Suppose I have most probably cationic form. I can say if this is the form, then it is not complete octet. So increase or a complete octet increase stability. This relations. Then here negative charge. So always a negative charge on electronegative element, charge on electronegative element increase stability. Means O minus 2 is feasible condition. Always we prefer this. We are not preferring this. So this is more stable because this is negative element and this is a negative charge. Then dissimilar charge. So I can say this is carbon, this is oxygen, I think. Then plus and carbon and oxygen, plus and minus. This form is not stable. This form is stable because positive and negative charge, they form the bond, so decrease the energy. Normally potential energy is depend on a charge. So what our goal is to decrease potential energy. Potential energy को decrease करने के लिए हमको क्या चाहिए? We have to decrease the charge. So what we find, we conclude here, what we find uncharged molecule, we find number of double bond, we find complete octet, we find negative charge on electronegative elements, and we find dissimilar charge by nearby atom. So dear student, this is a sequence you must have to remember in the form of CD-on. If you go directly a double bond, if you go a directly negative charge, you will not get the clear answer. So always my suggestions, मेरा ये मानना है कि आपको इसी डायरेक्शन में जाना है. पहले चार्ज, फिर डबल बॉन्ड, फिर ऑक्टेट, फिर नेगेटिव चार्ज, फिर dissimilar charge. Let us see this example. So I have an example. So this here, यहाँ मैंने क्या किया है कि रेजोनेटिंग स्ट्रक्चर ड्रॉ कर दिए है, क्योंकि लास्ट लेक्चर में हमने सीखा था और पढ़ा था how to draw the resonating structure. So among this structure 2, according to CD-on, the first we see charge. Okay, this is an uncharged molecule. So I can say among these two available structure, this is stable structure. Let us see this example number B. According to CD-on, this is uncharged and this is charge. This is charge and this is uncharged. As we had discussed about, uncharged is more stable, So this is a more stable structure. Let us come down. Both the structure in a C are a charge. Both the structure has charge. So we are getting a similarity at here. We cannot conclude from the C. Then move where? D. So double bond. Normally double bond is more in case of the structure compared to this one. So what I suggest is increase double bond, increase a stability, because bond formation is a exothermic process, and so energy will expel out, so there is decrease in potential energy. Let us come to the D. So according to CD-on, both the structure have charge. Yes, both the structure have charge. Next, both the structure containing double bond. Yes, both the structure containing double bond. So what I suggest, the structure cannot be solved from the CD also. Now where we move to the octet. But student, when there is a anion, then there is no need to see octet. Octet is very important in cation. In case of cation, octet is important. Okay, let us go ahead. So after that, it's a negative charge per molecule, so there is no required to see the octet. Let us go a negative. So here a negative charge in oxygen, and in the structure of this one a negative charge is on the carbon. So among this carbon and among this oxygen, which is more negative, I had explained it in inductive effect, a sequence of electronegativity. If you have not seen, please go through that, you get the confidence. So here the oxygen is more electronegative, so negative charge is on that case. So this is a more stable structure compared to this one. Okay, so this is the case where among the available all resonating structure, we can find the stable canonical structure. So let us go ahead. Suppose the structure this one, CD-on, we have to follow. Let us see this charge, both the structure containing a charge, double bond, here 2 pi bond, here also total 2 pi bond, multiple bond we can say, not a double bond. So the sequence is not clear from this double bond also. Then we go to the octet. I told you that there is no required to see this octet in case of negative charge, carbo anions. Now we reach to the N. What is N? A negative charge on electronegative element. Suppose the negative charge is here on the carbon, and negative charge here is on this nitrogens. So what I can say, among this carbon and nitrogen, which is electronegative, the nitrogen is more electronegative. So we come to the conclusion that this is a more stable structure. Let us come here, CD-on. So among these two structure, both the structure containing a charge, so not solved. Yes, it's solved from this double bond also. This is more structure, we come to the conclusion. Now if we move ahead, then see this octet. In this structure there is not complete octet, because this is 2 electron, this is also 2 electron, this is also 2 electron. So total number of electron for the carbon containing positive charge is 6 electron. So incomplete octet. As the complete octet increase the stability, so this is a less stable structure, this is a more stable structure. Let us go ahead. So among available this structure, we have to find the structure which is more stable. So I can say among these, the first 1, 2 and 3. So if we see here, Then I can say CD on charge. All the structure has charge. Yes, in case of double bond, this will win. This has more double bond. So double bond story is over. Octet. So both the structure has incomplete octet. So they are less stable. Negative charge on negative. Octet is also not solving the problem among these two structure. Negative charge on negative electronegative element. Here a positive charge on carbon, here a positive charge on carbon. So in both the structure, the charge is on the carbon. So what I can say, a dissimilar charge. When your problem is not solved, then you have to go to where? Dissimilar charge. Dissimilar charge means, I show here, this is a dissimilar charge. This is a negative charge. Lone pair means negative charge. This is positive charge. So positive negative by near one. So I can say this is first stable structure. This is second stable structure. This is a third or a last stable structure. So I can say it has low potential energy. It has low potential energy. So I can say this is a structure number 2, this is structure number 3, this is structure number 4. So let us come to the B according to Sedion. First see the charge. All the structure has charge, so problem is not solved. Find the double bond. Yes, this two structure has double bond, this one and this one. So which has more double bond? Both the structure has same pi bond, one pi bond. Then negative charge on, so negative charge or electronegative. So among them, I can say this is least stable structure. This is least. So सबसे कम. So among these two, which is more stable, I can say this is first, because this is more stable. After completion octet, we will not see here in case of negative charge. Electronegative element on negative charge. So this is first stable, this is a second, this is third or least. So what is our goal? Our goal is to find this structure, because this is very important for us. Let us go ahead. Among these three structure, which is more stable? It's very simple. According to CDON, charge, oh, it has no charge. So this is more stable. It's a more stable. Among these two structure, according to double bond, both the containing 3 double bond, octet, there is no need to see this octet, because negative charge in carbon and in positive charge and negative charge both have complete octet. If you want to see, I show you here. Suppose this is the structure of nitrogen. So this is 2 electron, this is 2 electron, this is also 2 electron, this is 2 electrons. So total number of electron is 8 electron, right? So in both the structure, octet is also complete. Charge is also, here also the positive charge on nitrogen, here also the positive charge on nitrogen, here negative charge on carbon, here negative charge on carbon. So I can say it is also not solved, but the next, when the solution not clear, then we go to the dissimilar charge. What is dissimilar charge? This two charge is nearby. So they attract with each other and decrease the potential energy. So first stable structure is this one. This is a second stable structure, and this is a third stable structure. Okay, I hope you get and you enjoy this study on. Suppose this is my one of the structure and I want to try to draw the resonating structure. So I told you that you must have to start from the negative charge. So here I get the structure like this. Next, I could get the structure like this. Now from here I have two structure possibilities. This same structure I had also explained you in case of uh, my previous video also. So here I draw the structure like this. From this side I can move now. These are the possible resonating structure. So among these all the structure, anyone is asked you which is most stable structure. So according to CD on all the structure containing charge, so problem could not be solved out. Then go to the double bond. This structure containing a 4 pi bond, remaining all the structure containing 3 pi bond. So my advice and my suggestions and answer is this is a most stable resonating structure. Most stable resonating structure. Let us go ahead. This is the possible structure. So among them we have to find which is less stable. First find out which is least stable. सबसे कम stable कौन है? So from the CD on, all the containing charge, yes. Double bond, this containing a 1 pi bond, this also containing 1 pi bond. So I can suggest that this is a least stable. सबसे कम है ये उसकी stability. Let us go ahead. After the double bond we move to the octet, but octet is also always complete. When your positive charge is on carbon, then and then only you have to check this octet, otherwise octet is always complete. So now this N, negative charge on negative, so I can say here is an opposite, a positive charge on a negative. So there are two possibility. One is negative charge on negative, then it is good, but then positive charge on a negative, this is a least stable. So first is this. So first stable structure ये होगा, first stable, because among this nitrogen and oxygen, which is more electronegative, this one. So the positive charge on that acquired, it is a less stable. So O minus is best compared to O plus. Among them also N minus is best compared to the N plus, but N plus is feasible because it is less electronegative. So it is, we can say it is toward the positive. नाइट्रोजन ऑक्सीजन से थोड़ा बहुत इलेक्ट्रोपॉजिटिव है, इसलिए उसके ऊपर पॉजिटिव चार्ज होगा, then it can acquire it. So the suggestion, this is least stable, this is a first stable canonical structure, this is a second canonical structure, canonical stable structure. Let us go ahead. Now up to here, whatever I told you and whatever I suggest you, when your structures are same or they are the resonating structure with each other, so if you see here, there is no change in this element, there is no change in this element, all are there on their own place. But if you see here, then there is a change in the there is change in the IUPAC name. They are not resonating structure. If you see here, these are not resonating structure. If they are not resonating structure, then dear student, we cannot use CD-on. If they are resonating structure, then we can use the CD-on. अगर वो resonating structure नहीं है तो हमें CD-on करना ही नहीं है. Then how to define which is more stable? So here if you see that the resonance effect is very high in case of this structure and in case of this structure, so here the train is very far, double single, double single, double single lone pair. Here also double single, double single, double lone pair. Here double single lone pair. So in case of this, the resonance is less. So this is a least stable among available structure. देखो ये सीढ़ी ऑन से करना नहीं है. So among these two, ये दोनों में तो same ट्रेन है. But dear student, I can say you that this is a linear resonance. This is a linear resonance and this is a non-linear resonance. And always resonance is in a one plane, then it could be a very effective. So I can say a linear resonance is more stable compared to cross resonance. Not it is not non-linear, but the ideal word is cross resonance. So which is first stable? Cross resonance. Which is first stable? This is first stable resonating stable structure. This is second, this one is third. ओके तो सीडी ऑन कब करना है? जब हमारे पास सब रेजोनेटिंग स्ट्रक्चर है और उसमें से हम फाइंड करना है. लेट अस गो अहेड. सो हाउ मेनी रेजोनेटिंग स्ट्रक्चर in the following? So I suggest you, I will try to draw the resonating structure. You also try, then and then you can learn it. So arrow is given to you how to draw. Just I want to show he is. I draw the structure this one. Okay, I try for this one. The remaining you try. NH2 plus, negative charge, this one and this one. Then let us go ahead. This one, this is. Let us go ahead. Then structure could be this one. Let us go ahead. Then structure would be like this. So dear student, this A and this B are different because a pi bond is here in case of this structure and this pi bond is not here. So these are the two resonating structure. So if anyone is ask you how many resonating structure you are getting for such a cyclic compound, then your answer should be a 5. 1, 2, 3, 4 and 5. One of this possibility is number of resonating structure. Number of resonating structure in case of benzene containing compound is equal to 3n plus 1. What is n? N is a number of ring. Here how many rings are there? It is 1. So there is 1. So I think people are confusing here. So I cannot say this one because you are going to be confused because it is not applicable to everywhere. So we will not go there. But my suggestions and my advice is you should have to see this is a 5 structure. 1, 2, 3, 4 and 5 because structure A and structure B are also different. So you try for the structure benzylic carbocation and free radical also. Here this is only 1 electron. So the half arrow, there are 2 electrons, so there is 2 arrow. So thank you and I hope you enjoy this lecture. My focus is only to show you which resonating structure is more stable. And if you like the CD on, then at least you write a CD on in a comment box. Thank you. Enjoy learning.